Hello and welcome to the eTech podcast with me, your host, Ryan Maughan. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. So for today's episode, we've got Mrinal Sood, who is the Director of Technical Marketing at a fascinating company called AEye. So welcome to the show, Mrinal.
Thanks for having me.
And I wonder if we could just get started by finding out a bit more about you and your background and where you're from.
Sure. I was always fond of technology kind of growing up. I was the kid who was always tinkering with computers and loved to play video games and PC gaming and things like that. So I always wanted to go into the technology world. And it wasn't until high school when I was kind of shadowing one of my cousins who worked in cell site design and who solved a lot of different RF problems for the telecom industry. And I thought that was really cool. So I said, okay, I'm going to also do electrical engineering. And I went on into that career. And it wasn't until my first internship I really understood, okay, what the corporate world is like. But at that time, I was working in the IT department at a startup in Chicago in 2010. And eventually the company was acquired by Accenture. And I never thought I would ever spend a day in the world of automotive in my career. And it wasn't until I got my second internship, I said, you know what, let me try and actually get hands-on experience with electronic design and apply my actual degree, which I was studying was electrical engineering. And that's when I got into Continental. That was my second internship doing validation and some testing work for the infotainment and telematic and radio division. And, I said, okay, what are some cool things I can do there? And they allowed me to design this little audio amplifier, which eventually made it to production. So I thought that was really rewarding. You're seeing people driving around cars and they're bumping up their music, and your circuit is potentially the amplifier that's powering some of the audio. And, I was kind of hooked. I said, okay, I'm going to stay in this kind of industry. And after graduating, I took on the full-time role and stayed in the electronics design team for transmission controllers, 4x4 control modules, and also the actuators and motors that are shifting power in the transfer case.
Right. Still at Conti at that point.
Yeah, still at Conti at that point. So I kind of over time realized that, do I want to stay in the world of circuit design and simulation, or do I want to get out and go into the public facing world? And I realized I wasn't the kind of person that wanted to spend 40, 50 years in the lab. So I decided, okay, I'm going to jump out, go into the quality side and do more project management, sales roles. And eventually I found where my heart shines best, which is in the mixture of robotics and technology and automotive. And that's the world of self-driving cars. This was about 6 years ago. I went into the sales and marketing side for lidars at Continental, doing a lot of different product development sales for new markets, markets that were just emerging, including drones and smart cities and smart infrastructure. That was sort of how I ventured into where I am.
Oh, fantastic. And then you took the jump. Did you go straight from working at a very big company like Continental to the startup, or was there a stepping stone in between?
No, definitely straight from the big world to the world of startups. I had migrated from the Midwest. I was a Chicago person and I moved to California. And after witnessing sort of the transformation in the mobility world, I was like, this is something I got to be a part of. And I said, okay, I've had enough time in big corporate. It's time to go to the startup world.
Oh, fantastic. And so that's straight into AEye, which is where you're at now. And so it's an interesting The name sounds like it says everything, about the company, but it's the letter A and actually the word I rather than the letter I. So could you just tell us a bit more about what you guys are doing there at AEye?
Sure. Going back, there was actually, it wasn't directly from there to AEye that I joined. I'd spent I had a couple of companies in between. The first was Innoviz Technologies, which was another lidar maker out of Israel. And I spent some time there until the pandemic hit. And then I was at Sense Photonics, which was more of a technology focused company within the lidar space. And that was acquired by a company called Ouster. And I joined AEye just last year, and it kind of reminds you the word is like artificial eye when you think of the two words together, and that's kind of really what their focus was when they started the company. Or the name of the company AEye, it's a play on the word artificial intelligence, but it's the brainchild of our founder Louis Dusan, who started the company in about 2013 because he developed a lot of different plane tracking and missile tracking systems for the military. And those were very complex kind of scenarios that you had to design for when you're tracking through radar and cameras and lidar sensors, but you're detecting things in the sky that are moving, very, very fast. So he said, let's see what technology and learnings I can take from there and apply it to the world of automotive. And he came up with the concept of a software-defined lidar platform, because all of the tracking systems that he designed for the military were all software-defined systems. So he said, we have to track pedestrians and bicycles and cars and trucks on the road. And there's all different types of targets. They all move at different speeds. We need to solve this problem through software. So he created AEye with the foundation of a software-defined lidar platform that we call Foresight. So
that kind of, we're going to have to roll back a bit here. And I warned you before we started, we were outside of my area of expertise now. So I'm going to ask you some silly questions, but I've not heard that expression before, a software-defined lidar platform. Was that it? Is that correct? Okay. What does that mean? Sounds cool, but what does that mean?
Sure, no problem. So if you think about the automotive industry, and you think about what Tesla has done and what they've been successful at, they simplified the vehicle. If you look at a Tesla car, it just has one touchscreen, and the touchscreen, you have all sorts of controls for your seat heater, your audio, radio, self-driving features. All of them are accessible through that one computer. Because what they did was they moved all the hardware complexity in cars to software. In the old school design, you would have so many different electronics that are controlling different functions of the car. So for example, you would have a radio and a radio control unit. You might have your heater, power seats, mirrors, doors. All those things would have separate little electronics. And what Tesla did was they moved all of that control to one central computer or a couple of computers that are now accessible through software. So they moved the hardware complexity and made a very capable hardware computer that could do all the functions, and then transferred all the complexity to software and made a UI, user interface that the user could then access all those functions. So that's sort of how you define like a software-defined car today. I'm just using an analogy here, but for lidar, the same thing applies. In the past, you had a lot of requirements given to you by automakers. Hey, we would like to see this person at this distance, or this object, a tire on the road at this distance. And they would give you requirements and you would build a hardware product. But as the scenario started changing, as autonomy got more and more complex, your requirements evolved. And companies would start to make a variety of different hardware, lidar sensors to solve those problems. And Louis said, that's not the right approach. Instead of having so many variations, it makes sense to have one lidar that can reconfigure itself through software and tackle all the different requirements that automakers are giving out. And that's sort of the way it was founded. And all we're doing really is we're telling a lidar to change its behavior on the fly, depending on where it's driving, where the car is driving, and how fast the car is driving, and what kind of maneuver it's executing. It can demand through the sensor different kinds of performance metrics. So we moved that hardware problem to software and allowed the car to demand a certain kind of performance from the sensor.
And what is it about the sensor itself that allows you to do that? Do you effectively have like an overspecified or a more highly specified sensing unit or processing unit that allows you to build that behavior into it?
Not quite, but in a way, a lidar can be broken out into three main components. So I'll go back at a higher level and just go into the lidar itself. A typical lidar sends out some light, and natural properties of everything in the world is it'll reflect some light back. And once some of the reflected light comes back, you're keeping track of when it came back, and the speed of light, which is a constant in the universe. And all you're saying is distance equals speed times time. We have now calculated how far away the object was. That's in essence what the lidar itself is doing. In order to make it software defined, those three pieces, which is the light, which is the laser, and how you spread that light, which is typically called your beam steering. Think about a laser as just a dot, and you're playing with your cat. You're moving your hand around so the cat can see the laser pointer moving. Similarly, in automotive lidar, you have a laser that shines light, but you have to move it around so it covers the whole field of view of the road and the world. So that's the beam steering. And then you have to receive that light once it's reflected back to your sensor in order to do that calculation, so you know how far away the objects were. What we've done in order to make it software defined is we have separated each individual module. So the laser transmit, the beam steering, and the light that we're receiving back, all of that is individually controlled separately, but they have feedback loops. So if you fire a laser, we can control exactly how much energy we put into each laser shot, how much distance we put between two laser shots. That allows us to control our resolution. Then if you look at the repetition rate, how fast you fire those laser shots, that controls our frame rate. So these three things are just the natural result of us programming the sensor laser. Same with the beam steering, where you fire that laser shot. And once you fire the laser shot and you wait for the reflected light to come back, based on where we fired the laser, we know where to look. Because if you say, I aimed my sensor laser there, okay, I only need to look there for the reflected light. So these three things being connected to each other and being individually programmed, that's what allowed us to make the lidar software defined. Because now on the fly, we can tell the sensor to behave differently based on the maneuver that's being performed for the car.
Right. So it's a much more configurable unit than your standard lidar would be. And you mentioned the beam steering. Is that like a physical mechanical part, or is that done electronically?
There are both mechanical and electronic options across the lidar market. What we have done is used a device. It's called a MEMS device, a micro electromechanical system. So it is mechanical in the sense that it's moving, but it is so small in the sense that our diameter of the MEMS is 1 millimeter, which is the same as the tip of a ballpoint pen. And we scan that at such a high frequency that we're able to, let's say you're, typical, if you're operating a camera system today for computer vision, you typically operate at, 60, 70 frames per second, very high frame rate. So this lidar sensors, they're typically operating today anywhere between 20 and 30 hertz. And because of our scanning device, because of the way we're scanning using such a tiny MEMS, we, from one frame to the next frame, we can entirely shift how our sensors configured, like I mentioned, because of the laser and the beam steering being configurable. And it can do that because of that beam steering device. It's so small, unlike a lot of our competitors who have such a large mass. These devices can be what are called spinning polygons or rotating mirrors. And they typically cannot move fast enough to change their behavior from frame to frame. Because if you're driving, let's say 120 kilometers per hour, which is highway speeds, you could take an exit off of a highway, or you could, go from a city street onto a highway, and you are accelerating pretty quickly. You cannot ever have any downtime where the sensor is not providing information or is providing inadequate information to the car. You always have to provide relevant data to the car because it's making real-time decisions. So if you have to change your behavior very quickly, you need something that can scan and change its scanning behavior very quickly. And that's why we chose this beam steering device. Going as a long answer to your question, but that beam steering device being so small with such a low mass allows us to maintain both the performance and sort of the reliability requirements that the car makers put out.
Cool. And it's so a MEMS beam steerer. Is that is it then basically a magnet that's not a magnet, sorry, a mirror that's moving, or is it actually some sort of lens that's moving to change it? What kind of
Yeah, it's a tiny mirror. You hit the nail on the head. Yeah.
Okay, so basically you've replaced because I think a lot of people will have seen the big sort of spinning. Almost looks a bit like an emergency light, like the old style lidars. You've replaced the big spinny bit with effectively a solid state MEMS component.
Exactly. And that's sort of always the nature of how technology gets introduced in the world of automotive, right? You start big, and when you have to go to production, you got to make it manufacturable. And those devices that are spinning, they're not robust to last typically 100,000 miles. So the automakers were looking for exactly something like this.
And hard to package in and all sorts of things like that. So this would be, because I hear people talk about solid state LiDAR systems. Is that how you would classify this as a solid state LiDAR system?
Correct. It's made with components that are all silicon or built on wafers. Yeah.
In terms of where you're at the moment with the business, you sort of, we talked about the startup piece and things like that, but what sort of traction do you have in the market with that? Where are you at as a company? Who are you working with, if you're allowed to say? It's normally the one difficult bit of these podcasts, but as much as you can tell us.
Yeah, I'll go into as much as I'm allowed to say. It's always a gray area to talk about everything, but we're pretty transparent. And when the company was founded, is founded with the philosophy that the software-defined LiDAR is the key to the future. And we've stuck to that. And we've fortunately been blessed that a lot of the industry has also agreed with our approach. So in the non-automotive market, we actually sell directly, where we create our own product and we tackle markets like smart infrastructure and smart cities and railroad and aerospace and defense applications. And for that market, we're actually partnered with, for aerospace and defense, we work with Booz Allen Hamilton, which is a very large contractor and allows us access into that market. But most importantly, for the world of automotive, that's where the automation is happening using LiDARs. We are fortunate to be working with our partner called Continental, which is my old employer.
Yeah.
And
now there's a coincidence.
And they, have been the market leader for a lot of ADAS systems already. They've sold more than 100 million radar modules to date. They are I believe, the largest radar supplier globally. They've sold a lot of monocam systems as well as stereo cam systems for forward-facing applications. and they launched their short range lidar product in 2020 or 2021, I believe. And that's used for more lane change and urban driving and parking kind of scenarios. But for a long time, they were looking for the right long range lidar architecture. They know the deficits that exist because they have the experience of deploying cameras and radars globally for more than 20, 25 years. So they knew a particular problem existed in the industry. If you think about today's systems, with radars and cameras, a lot of the features, they work quite well, staying in your lane, not hitting stuff, keeping up with the traffic ahead of you and slowing down, adaptive cruise control. All these systems work quite well. But if you look at the market, everybody is still selling pretty much a level 2 system. There are level 3 systems that are being introduced, but all of them are speed limited. They won't allow you to go more than 60 kilometers per hour, maybe. And that's not really good enough. At least here in the US, your morning commute to work, you're driving on the highways and you need to go 70, 80 miles per hour, 120 or so kilometers per hour. And none of the systems can do that safely. And the driver is required to take a given moment. These systems are not fully L3 at those speeds. And the reason is because the automakers are not being fed the kind of data that they need. So the biggest problem that's been a challenge is small obstacles on the road. A lot of times you'll see some road debris, a tire that's shredded from a truck, or some sort of a obstacle that's lying and, from some pickup truck that a contractor that's driving by, a ladder fell off or a pallet fell off, and it's staying in the lane that's directly ahead of you. And you have to determine as a perception system, okay, something's in the lane. Do I drive over it or do I slow down and do I have to change the lane and drive around it? And this kind of a problem gets exponentially harder the faster you're going, because the faster you're going, the longer you need to be able to see this object at the farther out. And typically you need to do this at a distance of about 200 meters. And I'm going back to the answer. It's a very long answer, but if you're trying to do that at 200 meters, you need something that has very high resolution in your lidar sensor and very long range together. You can't have one or the other. So Continental knew about this problem because they had already been selling a lot of different cameras and radar systems globally. So they did a long and exhaustive search of all the lidar architectures out there. And in 2020, they chose to partner with AEye. And our business relationship with them is we have a licensing model where they license our architecture, but they build the product, the automotive grade product, and sell it directly to both passenger car OEMs as well as commercial vehicle OEMs. And the reason they chose to license our technology over everybody else in the industry is because of that particular problem that we're able to solve. We can provide with very high confidence data that is both long range and high resolution to solve those over drivability challenges. Is something on the road? Do you have to drive over it or around it? We could do that at such long distances that it enables automakers to be able to go those high speeds on the highways. So eventually these systems that we're bringing will be allowing actual L3 deployments at highway speeds, which don't exist today.
I know one of the challenges that I've heard about was with these systems was to do with the power requirements for effectively that long range vision. I guess thinking simply, you need quite a powerful laser, you need a powerful system overall. How does that work with your product? Are you able to work with lower power consumption as well than a sort of traditional device?
It's an interesting question. I think that compared to camera systems, lidars will continue to consume a bit more power. It's a newer technology, but we get requirements from the automakers what the specification is, what we have to stay under. You typically don't get to choose when the system will be activated. That's up to the automakers. Do they want to keep it activated at all times to aid in emergency braking scenarios, or just keep it active during the highway portion or the driving portion above a certain velocity? but they give you requirements on your power consumption, and you typically have to operate below 25 watts. So we meet those requirements, including, with the architecture that we have today. And I would say we exceed those requirements. And this will evolve over the next 20 years, just like with the world of radar. When the radar modules were first introduced, it was very premium vehicles in the late 90s. And today you have radar that's standard. It's gotten smaller in form factor, lower power consumption, more performance, because that's sort of how all technology evolves. So
yeah,
the biggest benefit to the consumer, right? A lot of consumers don't like to. It's a odd scenario in the world, but they don't like to pay for redundancy and safety. They like to pay for new features.
Yeah, safety's not important until it is, and then it's too late.
Exactly, and this is what we're seeing. There's a particular problem that hasn't been solved yet, which is how do you let these autonomous systems go fast? Nobody can confidently go fast enough, and it's because that certain problems haven't been solved. So everybody's racing to solve those particular problems. And we believe that we are quite ready to start, activating those high-speed autonomous systems with our technology.
Oh, cool. Interesting. And actually, we're just seeing now production vehicles coming to market with lidar in as standard. I'm not sure if there's another one, but the first one that I've noticed is the new Volvo EX90 that's being launched. It's got a kind of unusual little bump at the top of the windscreen that to a British person looks a bit like it's a taxi, but it's a very expensive, very nice looking taxi. So that's a lidar system located in the car, built in as standard. Every vehicle will have one. I imagine that might even be a Conti system in there, but I'm not sure if it is or not. But do you see that starting to really pull through now with OEMs launching vehicles with lidar built into them in a sort of seamless way, rather than the big? Because some of the old integrations were pretty awful, and I saw which one? Fairly recently, like a couple of years ago, there was one of the OEMs had it kind of like coming up out of the bonnet on a, and it disappeared when you weren't using it and things. So it wasn't proper integration. But do you see vehicle integrated lidar properly integrated starting to come to the market?
Oh, absolutely. It's consumer is not going to purchase a vehicle that the consumer finds ugly. That's how I look at it, And these design teams get so much say in what goes on and how it's integrated in the vehicle that absolutely anything that they're going to bring to consumers directly, any brand in the car or in the world, whether it's Japanese, European, Chinese, North American brands, they're all focused on design. You could see 15, 20 years ago, all of those spinning lidar sensors, it started from a challenge. Okay, can we solve autonomy? Can we not? And over time, all the R&D fleets had a bunch of different integrations, but none of them were being sold to consumers directly. They were all either data collection vehicles or just pilots. But for passenger cars that consumers are actually buying, design matters. And they're studying all the different locations of integration in the grille, behind the windshield, in the roof. There hasn't been something that I think everybody is going to agree on. Everyone's going to take a slightly different approach, but that's kind of the benefit of the free market, right? We're going to see where consumers tend to be attracted towards what kind of sensor integration. Yeah,
it's an interesting big sort of difference. I actually was with some people this morning looking at a truck with autonomous system retrofitted, and the big camera installation, sensor installation. A few times I've been in America and seen is it Waymo, I think, with the cars with the big roof box, and they kind of have all the sensors hanging over the top. It's like, that's not a production solution. That's a kind of, there's almost looking at that looks impossible to package all of that down into something that would fit the car. But your kind of technology will enable these things to be quite seamlessly integrated into the vehicle in a way where you probably won't even really notice that they're there. So there's a couple of questions I was wondering about. So we've got, different levels. You were talking about level 2, level 3 in coming through in ADAS systems. What do you see in terms of the timeline for, getting to sort of level 3, 4 being commonplace in the market? You must kind of have fairly good visibility of programs because you would be, seeing your products start to get used more and more. What do you think the timeline is going to look like for level 3, level 4 systems coming into the market?
Yeah, this is a question that gets brought up quite a bit. Everybody's waiting, and the promised deadlines have passed from a lot of companies. But I don't have a magic ball on this either. But I think we're already seeing level 3 systems being deployed now, although they're speed limited. I think in the next 2 years we'll start to see more level 3 systems at higher speeds. But true, level 4, where you can just sleep in the car and wake up in your own car that you purchased, I think we're still a number of years away, maybe even a decade away from something like that truly you purchase and you can end to end go to sleep at night, wake up in a national park, and you own the car. It's not a service-based fleet. Those kinds of vehicles are still quite a bit away. But we're seeing in San Francisco, Cruise is already doing rides. We've seen Waymo doing rides as well, both in, I think Cruise just announced they're launching in Japan, I believe yesterday or a couple of days ago they announced. So we're seeing expansions of these systems. And the biggest challenge that exists is what Mother Nature throws at us. It's very easy to drive in sunny California, but it's very difficult to drive in pothole-filled, snowy winters of Detroit. So
yeah. The vehicle people I was with this morning were advocating the northeast of England's a great place to do all of your testing because the weather's awful. Yeah.
So it's gonna, and this is something that I would say that the original pioneers of the industry, they knew that they could solve a lot of the problems. But when you consider the environmental factors globally, not just in a little city state, but globally, where automakers have to sell everywhere, right? All the way from Alaska to the Sahara Desert. You got to be able to get these systems functional everywhere. So it'll take some more time. I think we're still at least 10 years away from something that consumers can buy like that. But
yeah, well, and I hope it does. I mean, for a couple of reasons. Partly, it excites me that sort of connectivity aspect of actually making sort of end-to-end journeys in your own vehicle, but being able to use the time for something else, legally, rather than at the moment. I mean, the number of accidents caused by people being distracted by texting and phones and such like, they're getting rid of that. The improvement to sort of human life and productivity and accident reduction and the savings associated with that are just staggering. Passenger cars is one thing, commercial vehicles is another altogether. So I'd really like to see these systems coming into commercial vehicles in terms of just purely from the accident prevention point of view. But the other question that I had is kind of connected really to the point you're just making. So maybe you've sort of answered it already. But I mean, this week was driving in my Volvo and the pilot assist system engaged, which is great. But level 2, I guess. But the weather was terrible. I live in the UK, so that's something that we're used to. And but the first time that I've really driven that car in that kind of weather, and it took me a while to realize, but the pilot assist system was not engaging. And I didn't know why, but it was because the windscreen was getting very dirty. So I ended up having to, be really sort of on top of cleaning the windscreen. And it was just sort of, on this long journey I was on, I noticed I had to do that and to keep the pilot assist system happy. So for your kind of technology, how does that figure that kind of dealing with the weather and sensor cleaning and all that sort of stuff? Is that a big deal or not so much of a big deal with your sort of technology?
Oh, it's definitely going to be something that automakers plan for. So luckily we're partnered with Continental and they've solved for this through accessories, right? If you have, for example, a sensor mounted in the exterior of the vehicle in the grille, and it's negative 30 degrees outside, it's going to have frost built up, right? When you go in the morning, overnight, it'll accumulate. So they have a defroster built into the window of the sensor. So you have a defrost cycle, so it's ready to go. Kind of like when you preheat your car, you're getting it warmed up before you drive away. Then similar things going to happen. They have washer solutions, so similar to headlamp washing solutions that exist today. You have a little nozzle that sends out high pressure water shots or solution shots to clean the window in case of mosquitoes or bugs accumulating when you're driving. So all these things for any optical sensor will be a challenge, but you have to plan for that depending on where the automaker is integrating it. And actually, same thing applies for compressed air. They have a little compressor in the car and nozzles going out, so you do bursts of drying cycles, so you don't have too much water accumulating.
Okay, interesting. I haven't heard of that. I haven't seen it, so that's interesting. Compressed air to blow water off. That's a good approach. Well, what about then external weather? So in terms of the presumably heavy snowfall and kind of heavy rain and things like that start to cause issues for optical sensors. How are you dealing with that?
Good question. It's not necessarily a thing that you're quote unquote dealing with. Anytime an optical sensor is facing snow or rain, it's gonna result in some sort of a degradation, right? If you're sending light and something is there in the medium that's obscuring the light, you're gonna have a little bit of a loss of signal. And that's true for fog, it's true for snow, it's true for rain. But in the sensor, we have what we call echoes. So for one pulse that we send out, we receive a bunch of echoes. So if you think about, light shining through a canopy of tree leaves and hitting the ground, some of the light will hit the tree leaves and some of it will make it to the ground. And same thing applies for lidar. When we're sending out light pulses, some things may hit the snowflakes in the air or the raindrops in the air, but as it travels through it, some of that faint light will hit the target, which is pedestrian or the road or the tree or whatever, and it'll come back. So we're able to image through some density of these obscurations, but if it's, of course, extremely thick fog, extremely heavy blizzard happening, then you're going to have a lot more degradation. But the nice thing is, in those environments, you're, again, not going to go 120 kilometers per hour. You're going to go much, much slower. So your range requirement also goes significantly down. You don't have to see something 300 meters away if you're in heavy blizzard, because you're probably not going to be driving that fast. You shouldn't be driving that fast.
Yeah, we've all seen those YouTube videos where you just think, oh my goodness, what were they thinking?
Exactly. So it's always going to be a problem for optical sensors, but we've designed an architecture that can help with the obscurations.
In theory, I guess, I know this is sort of outside of your company's scope, but in effect, you've got a pretty hybrid system of sensors on the vehicle. It's unlikely. I know some people talk very publicly about, maybe just having vision systems and being able to do quite a lot just with vision. But you've got these hybrid sensor systems. You've got vision from conventional stereo cameras, and presumably that won't go away even with the addition of lidar, and you've got radar as well on there. So these things, do you see that remaining like a full kind of big hybrid system like that with lots of different sensing systems, or do you think it might actually kind of standardize on a reduced sensor set? Because you could, I guess, lidar could replace quite a bit of that.
Although the capability is there in terms of some of the resolution and accuracy, you can achieve pretty high resolution and accuracy compared to the radars. We fundamentally believe in redundancy at AEye, and so does our partner Continental. They believe in redundant approaches to sensing, so that includes operating in the visible spectrum and the near IR spectrum, and operating in the gigahertz spectrum for radar. So we think the future will shift towards raw fusion, fusing the raw data from cameras and radars and lidars together. And the reason is, again, going back to what you just brought up, which is the adverse weather. if you do have optical sensors, which are cameras and lidars, they will have some form of degradation in the snow, fog, rain, and snow conditions. But the radar typically maintains its performance. You might have in extreme heavy rainfall, some artifacts show up, but for the most part, it's not affected by inclement weather. So that's why you need the redundancy. If you're operating in good sunlight conditions, your primary sensor might remain camera, and when it's blinded, use the lidar. But in adverse weather conditions, you might primarily rely on high resolution radar. So, we believe that all three sensors working together are the only way that you're going to get true safe autonomy at high speeds. Because if you omit a sensor, then the shortcomings from the other sensors are not bridged. And that's kind of the goal that we're bringing in from a lidar perspective. If you think about it, I brought up the highway small obstacle problem because that hasn't been solved. It hasn't been solved with cameras alone. It hasn't been solved with radars alone, and it hasn't been solved with cameras and radars together. And we're bridging that gap. So just like that, in any sensor, you kind of have to fall back to one of the other sensors to say, okay, I'm not performing as well. Can you take over?
Yeah. Yeah. And bringing all the data together just gives you that rich kind of stream under any condition just about that you can process and then do all of your driving control off that. Yeah, that makes sense. So you mentioned earlier on, right at the start, we talked a lot about automotive and a lot about your relationship with Conti, but you mentioned other markets and other kind of applications for your technology. I wonder if you just could tell us a bit about that. What kind of other interesting spaces are you working in, and where else might we start to see this kind of tech coming?
Definitely. One of our biggest focuses outside of automotive is the world of smart infrastructure. So cities are utilizing lidar technology, where we're participating in a lot of pilot programs for smart tolling, smart intersections, and highway incident detection. So smart tolling is actually it's a benefit to the cities. A lot of times what happens is the traffic that's moving in, they're unable to identify how much toll to charge, especially in automated tolling systems today. So they're trying to utilize lidar to say, okay, that's a 2-axle vehicle versus a 4-axle vehicle, so they can charge the appropriate amount of toll, so they're not missing any revenue from motorists. So that's one application. That's to the benefit of the cities. On the other hand, at intersections, it's to the benefit of the pedestrians. So what they're trying to do is, if you have a lot of vulnerable road users, expectant mothers, you have people with strollers or wheelchairs or crutches, and you see someone like that at the intersection, you can identify them, stop the traffic in all directions, prioritize until they have finished crossing the road, and then resume traffic flow. So that way, there's less chances of incidents and accidents.
That's a really good idea, especially in the US, because the pedestrian crosswalks are notoriously fast. Even as an able-bodied person, you're sometimes struggling to get across in time. So yeah, no, that's really interesting. Sort of
yeah. And with timer-based systems, which exist, sometimes there's not enough time for those folks, right? So you have to make sure until they're fully finished. So you can do that with tracking them through lidar.
Yeah. Sometimes there's not enough time for me. Yeah. So, yes, lots and lots of potential applications. Obviously, I guess the sort of defense space and things like that kind of go without saying. Is that an important market for you in the defense sector?
Yeah, I won't go too much into the applications there, but defense itself, if you're doing, army applications versus, let's say the border applications, there's completely different use cases, but a lot of the same challenges that apply for automotive are relevant in defense as well, like cameras not operating as well in nighttime or direct sunlight, and you have to track something or detect something. They're bridging those shortcomings with lidar. The automatic incident detection on highway application, I think you'll find this one interesting, because there's a lot of times on highways you'll get someone with a flat tire or someone that's pulled over, or someone rear ends the person ahead and they're pulled over to the side, and it takes a lot of time sometimes for emergency vehicles to come in or someone to contact them if someone doesn't have their phone is dead or whatever. So now cities are implementing LiDAR sensors on highways, and they're trying to basically look at how many cars go through which lanes at what time of the day, if how much gap is between one vehicle to the next to see what the congestion is. And if someone is, let's say, pulled over to the side, they can identify, do we need to send an emergency vehicle for assistance and block off a lane or not? Because a lot of times you might have folks that get into an accident and they get pulled over, but you won't find out until you pretty much approach that accident that, okay, this is what's obstructing the lane. So do we need to send someone that blocks the lane much farther behind them for the traffic flow optimization? So this kind of a application in the past has been tried with cameras, but they simply can't keep up with when the sun is directly hitting them at sunset time, which is what rush hour is. If you're going west at 5 o'clock, typically that's sunset, and when the camera is hitting the sun is hitting the cameras directly, they lose critical information during rush hour. So they're trying to find, okay, how do we just detect 500 or a kilometer stretch of the road at one time using LiDAR? That's a really cool application for cities.
And I guess if your LiDAR system all of a sudden goes from being the big thing with a big spinny mirror and all that kind of gubbins that's quite difficult and expensive to a small solid state sensing unit, you can put lots of these out there.
Precisely. And we can do it with two sensors. We can cover a kilometer because of our range capability, which is really, really advantageous.
There's not many camera systems that could do that, even with an operator, let alone autonomously. There's some really cool applications with, systems mounted onto UAVs and drones and stuff like that, scanning, I think collision accident investigation scanning, stuff like that. Almost like portable inspection equipment. It's just such a huge market. It's really, really interesting, really great to see what you guys are doing. So last question, conscious of the time, but it's been really interesting finding out more about what you guys do. So this morning I did spend some time with a commercial vehicle company. So they're developing autonomous trucks, and that's really important area. Safety is a thing, but obviously big shortage of truck drivers and skilled labor for trucks and off-highway machinery and these kind of things. What do you see happening in that market? So on-highway commercial, but also, off-highway commercial vehicles or mining equipment, all that kind of stuff. Do you see a lot of activity around that space and a pull for your technology, or are they using the conventional stuff? How's that going?
Definitely. And that's another area we do focus in. You can kind of look at the commercial vehicle side as both on and off highway. We've seen a shift in autonomy over the past 5 years. There was a big push towards robotaxis to transport passengers from point A to point B, which turned out to be a little bit more challenging than just doing highway depot to depot. So we're seeing a big trend where companies are moving towards hub to hub automation on the highway. And that's majority of U.S. highway truck driving, moving goods in from the ports. Once it arrives from the ports, moving the goods inwards from trains and trucks. And the trucking part is just going from point A to point B, from hub to hub on the highways, that's being automated. And again, because of our long range detection capability, we're seeing a big demand on that side from the trucking logistics side. And on the off highway, you could kind of break the problem down into two sections. You have the bulldozers, which are digging the ground, that are always changing the topography of the environment they're operating in. And that, the sensors are needed to map out the world in that kind of a world in real time. And the other aspect of it are the mining haul trucks. Once the bulldozer has dug up all the ground, these haul trucks take that material and go back towards a site where they dump it for, inspection, let's say, extracting the material that they've dug up. So those haul trucks are going from one site where the digging is happening to the warehouse. So that leg is being automated and the digging is being automated. And both have a need for LiDAR. We're seeing the demand from both sides, but the use case is very different. In one case, you're mapping out the ground to see the topography. And in the other, you're actually just doing standard obstacle avoidance, making sure you're going from the site to the warehouse back and forth in a very dusty environment. And you have to be able to pick up obstacles through the dust. So it's really interesting where the autonomy trends are happening.
And in some ways, those kind of applications where there's like a sort of commercial payback, like a quick commercial, like self-driving cars is great in the future, and I think that will have such a big impact on transport systems and the way we move. But in the near term, like if you can't hire drivers or they're very expensive, and you can automate your mining site, your quarry or whatever, and there's a direct, immediate financial benefits that you can start to get out of that, let alone the safety side of things or productivity. That's, there's sure to be a pull from those kind of applications. So where there's a really clear, tangible benefit, that's kind of, stronger pull creates the follow the money, as they say.
Oh yeah, absolutely. And in the trucking space on highways, you look at the total cost of your fleet, and it includes the driver wages, the training, the fuel economy, the maintenance of the brakes, and all of those things can be lowered in existing trucks with addition of lidar, and of course with the new trucks being designed for this from the ground up. Because even if you think about your brakes, which is a big part of the cost of maintenance, if you could detect something really far away, you can let off the throttle instead of pressing the brakes abruptly and increase the lifespan of the brakes. These simple things add up to the net benefit for the fleets, and they recognize that. This is why there is a big focus on the commercial vehicle space now. Yeah,
to prevent damage. I mean, the application was a sort of low speed, like moving things off road, so inside of factories or ports and things like that. But the trucks they use today are built really, they're super tough. They're designed to be bashed into walls and kind of driven in a really abusive, aggressive way by a person who's not all that bothered about, scratching the paintwork. But even that, as an autonomous product, or even with a level of ADAS to sort of protect its, just can transform that product. One of the sayings that it's funny, I saw it just yesterday because the person that I heard it from was posting some stuff online. But one of the sayings that I really like, and it's relevant, I think, to you guys, was replacing elephants with ants. Kind of, if you think about a lot of applications, you have big trucks on highway, big trucks. We're off highway, those huge mining trucks, big excavators, etc. And a lot of that's productivity, and it's because the driver, the operator, is the expensive thing. So we want to move as much product as we can with the driver. But if I'm thinking of further ahead here to full autonomy rather than but if we can take the driver cost out of the equation, it potentially could just completely transform the sort of vehicles on the road even. And up until now, one of the arguments against that has been, but the sensors you need are so expensive, so you're still going to want to have, that sensing suite, it doing a lot of work, etc. But with a movement to much lower cost solid state sensors to implement these sort of things, like maybe actually we could see much, a more kind of like an ant concept, and smaller vehicles moving loads around more appropriately.
Yeah, that's let's see what happens. I think it's not far off. I think everybody will be studying the cost of the vehicle they're designing and the benefit of the automation, and seeing what the next vehicle looks like. I think that mobility space, we're going to see the same thing with buses, right? If you have bus routes, you don't necessarily have to have 50, 60 people per bus. You could just have 10 people on routes and do them more frequently. But, at least in very populated cities.
Certainly, and the ability to take vehicles out of service more easily, to deal with peaks and stuff. But the whole transport system today, particularly in Europe, where we have more rail, we have the hub and spoke kind of system, and it's quite inconvenient actually going from home to somewhere to, one form of transport to another, to and you're then moving a lot of people, but in a very, very large train, and there's all sorts of issues with that if the train isn't fully loaded, and just this kind of the shift in the way we move people and do all of that, I think is the next few years are going to be really interesting. But look, I'm conscious of the time and taking up loads of your time, and we could talk all day. Actually, we could geek out on this all day long, but we should stop now. So, Mrinal, thank you very much for taking the time out to join me today. It's been super interesting.
Likewise, Ryan. Thank you for having me. It's a great start to my morning.